Hello and welcome to C++ Weekly. I am your host, Jason Turner, and yes, I'm available for things that you might want to hire me for. In this episode, I want to talk about the constexpr evolution of standard array. I'm going to use my CPP Evo website, which does need to be rebuilt now that C++ 26 has been finalized. I will get to that almost certainly before this episode airs. Before I get into this, I want to remind you that I have upcoming workshops at NDC TechTown and CPPCon. Be sure to check out the links to those. I want to run through the constexpr evolution of standard array because I think this is an important story about how we design code and how we think about constexpr. There is a general thought process of I do not need to make something constexpr because I don't personally see a use for that thing being constexpr. And I will show you what kind of issues this caused with standard array. This is the diff set from C++ 11 to C++ 14 with standard array. Now notice a couple of things. First is that in C++ 11 mode, a constexpr member function was implicitly const. So when they moved from C++ 11 to C++ 14, they did have to explicitly add const to these member functions that were intended to be read-only. So in C++ 11, the only members that were constexpr were the size, max size, and empty. Data was not, front was not, back was not. We can browse that here with the C++ 11 archive link. Sorry for the switch to light mode here. Let's go ahead and take another quick look at this. Size, max size, and empty were all constexpr in C++ 11. Okay. Data was not, the iterators were not. How was I supposed to use my array, a constexpr array, at compile time in C++ 11? Actually, it doesn't seem that we were able to access the elements of an array in C++ 11 mode at compile time whatsoever. We were only able to access the size of the thing at compile time. And there's no reason that we couldn't have. In C++ 14, many of these things did become constexpr. We get the constexpr operator bracket, we get constexpr at, we get constexpr front, we get constexpr back. And the standard get is constexpr. So take a moment to look at this. This is the C++ 14 difference. Notice that the mutating operator bracket, index operator, is not constexpr. So I'll demonstrate the problem here. Let's take this to C++ 11 mode. This is a constexpr object. Its values are const. I am not currently operating at compile time, if you will. C++ 11 had severe limitations as to what you could do in constexpr. It could just be a single return statement. So I might have been able to do something like this. In C++ 11 mode, this is perfectly fine. So this is the limitations that we had in C++ 11. And let's be fair, the limitations of C++ 11 itself did drastically limit what we could do here. Let's go ahead and go to C++ 14, where I can start to make my point more soundly. In C++ 14 mode, I am allowed to have multiple statements in my constexpr functions. Now, let's say I want to update one of these values. I'm going to change the value at location 1 to 2. I can't do that. Call to non-constexpr function. It's a warning because I'm not assigning it to a constexpr variable. Let's force evaluation to compile time and do this. Now this should be an error. Yes, compilation error. Call to non-constexpr function during constant evaluation, basically. Okay, this is annoying, so I can't do that. Can I do .data of 1? No, I cannot. Let's make sure that the base case works. Okay, so data is not constexpr. And this is real-world problems that I ran up against while I was trying to use array. So I had to go and learn that I can do this if I want to. I can use the free function, but I can't use the member function. Now the member function absolutely could have been constexpr in C++ 14. nothing stopped that from happening. So this was overlooked. We got constexpr operator bracket, index operator, but not for mutating things. So if we wanted to mutate it, same is true for front and back and at, etc. The only way to mutate it is if we used the free functions, which is incredibly, I would say, fascinating, I guess, that I have to go to the free function, forget, how does the free function work that it's able to do this and I'm not able to do it? I don't know, but it does. All right, then let's move to C++ 17. And now for C++ 17, we get constexpr begin, constexpr end, constexpr rbegin, constexpr rend. These things also could have been implemented in C++ 14. There's no technical limitation here, although some of them are probably defined in terms of other standard library concepts, which is why they weren't yet constexpr, but it looks pretty good, except we don't get constexpr swap, and we don't get constexpr fill. And why don't we have constexpr fill? Because the standard algorithm for fill is not yet constexpr in C++ 17. Yeah, we start to see the rest of these member functions become constexpr. But we're in C++ 17 mode. Now let's teleport to C++ 20 mode. And now finally, we start to see that fill and swap are finally constexpr, and now all of the member functions of standard array are finally constexpr, and all the free function helpers are finally constexpr. So many of the things were possible in 11, but wouldn't have gained us anything. By the time we got to 14, this is all technically possible. But it took from 14 to 17 to 20, it took 6 years longer than necessary because not everyone saw the utility in making the entire thing constexpr. So what I want you to take away from this episode, and please don't take away something else, is that even though you may not see the need for something that is constexpr today, if it can be constexpr, go ahead and make it constexpr to save us those extra 6 years. Thanks for watching this episode of C++ Weekly. Be sure to subscribe, and I'll catch you in the next episode.